Question: show that x upon 1 plus x is less than log 1 plus x is less than x for x greater than minus 1 and x not equal to 0. That means not equal to 0. That means x is in between minus 1 and less than 0. In the earlier video, I have done already for x greater than 0. The first method is Lagrange mean value theorem. Here fx is log 1 plus x on your x to 0 because x is less than 0. Now first fx is continuous on x to 0, x less than 0, 2 and x greater than minus 1. This needs to be there. And here also you need to write not just less than 0, greater than minus 1 and less than 0. First, fx is derivable on x to 0. There exists a theta lying between 0 and 1 such that f dash theta is equal to f of 0 minus f of x upon 0 minus x. This is now fx is log 1 plus x. So f of 0 is log 1 plus 0. This is log 1 and nothing but 0. And f dash of x is 1 over 1 plus x. And you know this. And then f dash theta. If that's theta x, sorry, I made a mistake here. If that's theta x, f dash theta x, f dash theta x, f dash theta x is equal to 1 theta x is equal to, use this now. Wait a minute. Use this now. Use this. f0 is 0 minus log 1 plus x upon 0 minus x is nothing but log 1 plus x upon x. Now cross multiply this. So you get x 1 plus x is equal to log 1 plus x. Now this is an important equation. Now the first thing is theta is in between 0 and 1 and x is given to be less than 0. Remember theta x is greater than x. Why? See, x is a number less than 0, greater than 1. So you take any number x. See the example. Take x equal to minus 0.5 and take theta equal to 0.2. Now you multiply theta and x. Multiply theta and x. You will get 0.2 into 0.5. That is nothing but minus 0.5. Sorry, this is minus. So this is 10, that is 0. Minus 0.1. This is minus 0.1 is always greater than 0 minus 0.5 is always greater than minus 0.5 minus 0.1. This is minus 0.1 is greater than 0.5. देखो ये थीटा लाई करता है 1 और 0 के बीच में, x is less than 0, थीटा x is greater than x, तो x is equal to minus 0.5, थीटा is equal to 0.2 you take. तो थीटा 0 और 1 के बीच में लाई करता है, पॉजिटिव वैल्यू है, x is a negative value less than 0 greater than minus 1. So theta x 0.2 into minus 0.5 is minus 0.1 is greater than minus 0.5. ये बात समझ में आ गया होगा. अब that's why this is greater than this. Let's rub all this. No need of all this now. Now from here I can say, now from here I can say, 1 plus theta x is greater than 1 plus x. Now 1 upon 1 plus theta x is less than 1 upon 1 plus x. Inequality changes. Now now you multiply x on both sides. So x 1 plus theta x is greater than x over 1 plus xy as x is a negative quantity. जैसे कि x नेगेटिव क्वांटिटी है, नेगेटिव क्वांटिटी से मल्टीप्लाई करोगे तो इनइक्वालिटी चेंज हो जाएगा. द इनइक्वालिटी विल चेंज इफ यू मल्टीप्लाई विद अ नेगेटिव x, with a negative quantity of x, and this quantity is nothing but, if you see, this is this. Therefore the first equation is log 1 plus x is greater than x upon upon 1 plus x upon 1 plus x. This does the job. This is equation number 1. Now again you see one thing. Here you take this, use इसको लो और इसको लो. तो theta x again let's write in the next line. Wait a minute. Again theta x is less than 0. Why? Theta को कोई भी क्वांटिटी ले लो. You take theta 0.2. You take x as say 0.3 minus 0.3, 0.3. So this becomes 0.06 with a minus sign. 0.06 with a minus sign. Yeah, minus 2 log. If you take this and if you take this 3, it becomes this. This is quantity is less than 0. Therefore, this quantity is less than 0. Now add 1 on both sides. Now I'm adding 1 on both sides. Will be less than 1 only. Why? I'll tell you. See the example. Suppose you take the example that I took. Theta x was minus 0.06. Now 1 plus minus 0.06 is nothing but 0.04, which is less than 1. So this is a valid statement. This is a valid statement. Now you see here 1 upon 1 plus theta x is greater than 1. Now as x is a negative quantity, so you multiply by x 1 plus theta x is less than x as x is a negative quantity. And what is this? This is nothing but log 1 plus x. This implies log 1 plus x is less than x. This is equation number 2. From equation 1 you have this. From equation 2 you have this. Combining 1 and 2, you have x upon 1 plus x is log 1 plus x is less than x. Reminding you that what is increasing function and a decreasing function. See hx as a function. If I take the derivative of this function, this is greater than 0, implies hx is increasing. That is, if x1 is less than x2, then h implies hx1 is less than hx2. This is increasing. And suppose I take this same function happens to be like this. H dot x is less than 0, implies hx is decreasing a function. I have to write a function. That is x1 less than x2 implies hx1 is greater than hx2. That's the idea. Now we will use the same idea. Let us define the function. Fx is like log x 1 plus x minus x upon 1 plus x. The other function is phi x, which is x minus log 1 plus x. Similarly, so f dash x. So your f dash x. F dash x is equal to 1 upon 1 plus x. Now you know that how to do that differentiation. I'm not into 1 minus x, and this will be 0 plus 1 upon 1 plus x whole square, and this phi dash x is now 1 minus, you have 1 upon 1 plus x. Now you take the LCM here, f dash x, you have this as 1 plus x minus 1 plus x upon 1 plus x whole square, and here you have phi dash x equal to 1 plus x minus 1 upon 1 plus x. Now you cancel this, you cancel this and this, you cancel this and this. So what you have is f dash x is x upon 1 plus x whole square, and then you have phi dash x equal to x upon 1 plus x. Now see, now the point is here, the point that is x is in between minus 1 and 0. This is given to me already. That means if I add 1 on both sides, so this will become 0, this will become 1 plus x and less than 1. So this quantity is now greater than 1. So 1 plus x is now greater than 1. This quantity is of course, and of course 1 plus x is therefore implies 1 plus x is greater than 0, implies 1 plus x whole square is obviously greater than 0. So now the denominators are 0 in both the cases. Wait, let's rub them. Yes, the denominators are 0. Now see one thing. Take this x, this is and c. So therefore the x is in between, as x is in between this, wait a minute, as x is in between minus 1 and 0. So this quantity is the numerator जो numerator है वो तो negative हो गया, denominator positive है, यहाँ पे भी numerator negative है, denominator positive है. So everywhere in both the functions, both the f dash x and phi dash x, the denominator is positive and the numerator is negative. Therefore, f dash x is less than 0, comma phi dash x is also less than 0, implies fx is a decreasing function. Fx is a decreasing, fx and phi x are decreasing function, are decreasing function. Now you take this, since fx is decreasing, you can take, suppose you take this as your, this is your x and 0. You take x less than 0. So f of x is greater than f of 0. I have, because this is decreasing function, so f of x is greater than f of this. f of x is greater than, जो ये x1 है ये x2 है, तो x2 बड़ा हो जाएगा x1 से. तो f of x जो पीछे वाला है, देखो आई एम सेइंग दिस इज x1, दिस इज x2, so f of x1 will be greater than f of x2. That's the idea basically. So let's rub all this. The one which is behind, when the function it becomes greater. The one which is in the front, it will become smaller. जो पिछले वाला है वो बड़ा हो जाएगा, जो आगे वाला है वो छोटा हो जाएगा. What is fx? fx is log 1 plus x minus x upon 1 plus x, and we did the calculation earlier also. F of 0 is 0. So you take f of x as log 1 plus x minus x upon 1 plus x, and this is greater than 0, implies log 1 plus x is greater than x over 1 plus x. Equation number 1. Now for the phi dash x, for the phi x, for phi x, this is for fx, for fx. Now for phi x, you have to take the same interval. This implies phi of x, which was in the back, now will come in the front. Which was in the front will now go at the back. Phi of 0. What is phi of 0? Phi of x is what? X minus log 1 plus x. Now phi of 0 is equal to 0 minus log of 1. And this is nothing but 0 minus 0 is 0. So now you have this condition. this condition, that is phi of x is greater than 0, that is x minus log 1 plus x is greater than 0, implies x is greater than log 1 plus x. So this is equation number 2. From equation 1 and 2, you see, from equation 1 and 2, so you have this comes from equation 1, x over 1 plus x comes from equation 1, and 1 plus log x, and from here you get less than x. That is how it has been proved.